Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Make sure you sign your attendance. Okay. Where was my attendance? And basically, we already learned how to find volume of integration, right? And since some of you still cannot imagine what is happening, why we have to learn volume, how to get the volumes of integration, and what we must do in order to get the volume of integration from a compound area. We have to minus the volume with a bigger area minus with the smallest area, right? So to enhance those understandings so that you can see, I do have some animations for you to see so that it will make you more understand. Hoping this one will help you, and why we need to find compound areas, why we need to find volume integration and all that, how to find it. Will also be explained inside the videos, and those videos I'm taking it from YouTube, and that YouTube is Exam Solution. So use Exam Solution as your helper. Alright, so without further ado, can we go and see the videos?
And in this tutorial, what I'm going to show you is how we can find the volume of such a solid. And also, in a later tutorial, what I want to do is...
Alright, so I need to begin.
Hi. Now suppose we take a curve and we look at an area bounded by the curve, the x-axis and two vertical lines. Now if we take this area and spin it about the x-axis, we generate what is called a solid of revolution. And in this tutorial, what I'm going to show you is how we can find the volume of such a solid. And also, in a later tutorial, what I want to do is extend this work to taking an area trapped between two curves and now revolve it around the x-axis. You'll notice we generate this solid of revolution, kind of like a funnel with this hollow in it, okay? And in these tutorials, we find volumes like this by using integration methods. Now suppose we have a finite region bounded by the curve y equals f of x, the x-axis, and the lines x equals x1 and x equals x2. And if we rotate this region about the x-axis through 360 degrees, or the equivalent of 2 pi radians, then what we generate is this solid of revolution. And if we want to find the volume of this solid of revolution, it can be shown that it's equal to pi times the integral of y squared with respect to x, going between the limits x1 to x2. So we've got our limits there, x1 to x2. Now I'm giving you this formula here without any proof. But in a later video, what I'll do is I'll show you how it is derived. But for now, all I want to do is just show you how we can use it. So we've got an example here. I've got the curve y equals x squared plus 1, and we have this region here bounded by the lines x equals 1 and x equals 3 and the x-axis. And if we rotate this through 2 pi radians, or 360 degrees about the x-axis, we generate this solid revolution. And if we're going to find out the volume of this, we'll call it the volume V. Then according to this equation up here, that volume V is going to equal pi times the integral of y squared, or y is x squared plus 1. So if we square that, we've got x squared plus 1, all squared, integrated with respect to x, going between the limits x is 1 to 3. So we're going from 1 to 3. So, in the usual way, what we would need to do is expand the brackets. So we've got the integral from 1 to 3 of, and expanding the brackets gives us x to the power 4 plus 2x squared plus 1. And we're integrating that then all with respect to x. And integrating this gives us x to the power 5 over 5 for that first term. Integrate the 2x squared with respect to x, and we get 2x cubed over 3. And finally, integrating 1 with respect to x just gives us x. And that's going between the limits then 1 to 3. And if we substitute our limits in, we've got, for the first one, when we put the 3 through, we've got 3 to the power 5 divided by 5, and then plus 2 times 3 cubed all over 3, and then plus 3. And then for that, we now subtract what we get when we put 1 through. So
Alright, so basically, this is what we are going to do. Initially, it is 2D, this is what we call area, bound by the function. And this one is volume. So the only difference between areas and volume you need to have pi and square. I didn't mention why is it pi, because it rotates 180. Rotate 180, revolve around the x-axis. Understand? So the increment of the pi basically rounded like a circle. That's why circles equation, a circle's area is what? Pi r square. So that's why revolve in a circle means pi y square. Understand? But most of the time, if you're using the x, if it revolves through the x-axis, make sure you use y square. Understand that? If it revolves through the y-axis, make sure x squared. That's the only difference. So the way you treat it for the volumes and the areas must be the same. Is it okay? Okay? So the others is just control. It's okay. Alright, so that is basically what we are supposed to learn today. Thank you so much. Let me check. Farzan, can you switch on the light? To enhance your understanding, can we try one of the past years? We will start from the areas, huh? So I will show you one step on how to do the past years. Okay. The first question. Are you guys ready? Sammy, wake up. Alright, the diagram shows the curve. I got a curve. And basically this is curve. Alright? So it's very clear and it's not complicated to see. Alright? It's very clear. The only thing you can see is there's so many alphabets here. Alright? So the A and B basically you all know. It shows you the what's the name? AB point. Showing you. What point is this? Yeah, stationary point. So what happened during stationary point? What happened during stationary point? The gradient dy dx is 0. Yes, equals to 0. Louder, louder. Don't be shy. And we also got C and D. So the C and D is just an intersection point between who? The line x equals to the x on B and also this line. Alright? And this line is not a tangent, just a line crossing the curve and this line. That's it. At the same time, the diagram shows the curve only on the positive side of the x. You're not clearly, you can see 0, x bigger than 0. That's what it means. X more than or equal 0. Has maximum A, minimum B. Understand the question. This is past year, 2009. The normal to the curve. Where is the normal to the curve? At C. So this is a normal to the curve. Means at that particular moment. So what you can see here, when there is a normal at this point, when there is a normal, this is the normal line. So where do you think will be the tangent? Okay. Where do you think will be the tangent line? To that point C. If the normal is this way, where is the tangent to that normal? Yeah. Slanted down 90 dB, but tangent to the curve. Okay? So this is a tangent at that particular same interest point. So this is the tangent, this is the normal line. Okay, fine. Now done. So the point C is given. How much is the point C? How much is point C? 2, 2, 2, 2, 2. So it means that x is 2, y is 2. Is it clear? Alright, now. Mix the normal to the curve at B. Oh, B also got normal. So this is the normal. See? Another normal here. B is also normal. Where is the tangent? So, where is the tangent to this normal at B? Horizontal. Parallel to the X, right? So this is B. B point. So do you know what is the X point for B? No, right? It's not given. Your job is to look for the coordinate. The first question asks you, find the coordinates of A and B. How to find coordinates of A and B? So make sure if you want to answer, understand A and B is what point? What point? Nagra? Stationary. Am I right? Right. Stationary point. So what is the property of stationary point? Jada? What gradient? dy dx equals to 0. So what do you need to do in order to find A and B here? dn. What must you do in order to get A and B coordinates? You know that dy dx equals to 0. So what do you need to do? And think. What do you need to do? Where can I get dy dx? Ask yourself. Keep asking. Where can I get dy dx? The equation, right? So the original equation, look for the curve original equation. So okay, I can find the dy dx only from here. So what I ask you, dy dx is what? dn. Yeah, so before that, can you find dy dx here? So dy dx is basically what? This is what? Huh? The first differential or the first derivative. Go ahead and do it. Okay, right. Come on. Come on, easy. Differentiate, differentiate. Wait. Alright, so remember the step. Summary. Remember how to differentiate? What is the step? The common step. First thing. Okay, faster lah. Bring forward the power. Make sure every operation, every term. So 1, 2, 3 term. So each term you must differentiate. So bring forward the power become 3x, then again square power reduce 1. Am I right? Simple step. This is differentiation, not integration. Integration is another thing. Differentiate. Before we learn integration, we learn differentiation first. So minus next. Okay. Minus 12 and power minus 1, right? Power reduce 1. Then next one, last one. Last. Finish. Term by term. Operation is okay. When you see operation between term, let term. If you don't see any operation between term, that is a pain. Alright, because you have to make sure there must be an operation between them. Understand that? It's easy for you to differentiate an integration when there is operation. Operation means minus or plus. The addition and the subtraction. But when things are multiples, this one you have to split them to make sure that they do have operation between. Does that mean? If the base is the same, the power will use the 1 as a plus the power or minus the power. Alright, now simplify. 3x squared minus 12x power of 1 plus 9. So, this is your dy dx expression. Am I right? So, parsing. I don't need parsing. Use so. Can I use this expression to find gradient at any point that I want, except not just A and B? Can I use this expression to find gradient of the tangent towards any point, not just A and B? Maybe. Why do you say maybe? You're not sure. Why you're not sure? Which part you are making you confused and not sure? Which part making you confused and not sure? Answer my question. My question is simple. This is dy dx, right? Dy dx is the first derivative, right? Gradient of who? Gradient of who? Dy dx represents gradient of what equation? Gradient of who? Dy dx. Hi. Gradient of who? Dy dx. Gradient of dy dx equals to gradient of who? The yeah. Yes. Gradient of who? Dy dx. Gradient of a tangent lah. Ayo, so many times to explain already. Tangent at any point. Any point. This is tangent. This is your curve. Am I right? Any point, as long you know what is the point, you can find the gradient. But in order to find those tangent gradient, you need to know what is the point. That only you use. Understand that? But now I only had A and B. Am I right? And A and B, I don't even need the point because I know at this particular time, this is all stationary length. So dy dx is always equals to 0. Am I right? But the others, not stationary, not these two, A and B, we can't assume it is 0. Understand that? Because at that particular time, they do have gradient. The dy dx is this. Understand what I mean? This curve? So basically dy dx again, what is dy dx? Equation or the gradient? Be careful, the gradient of a tangent. So from here you can find any gradient of a tangent at any point you want. As long you know, let's say I got C just now here, 2 and 2. Can I know what is the gradient of a tangent at this particular C and 2 and 2? I can. Am I right? Because I got a point. Listen, x and y is there. At the same time, I also got the expression for dy dx. Am I right? So we need this expression, we need the point. Then only you can look for the gradient of the tangent at that particular point. Okay? Any point. Okay, now this is your expression. Done. The next step. Data, what is the next step, Data? What should we do once we got dy dx? Secant? What secant? Why go for second derivative? We haven't finished the first question. To look for the A and B, the stationary point. This is his expression. The question is asking you coordinate A and B. I got dy dx. Come on. Come on, think Jaya before I go back to you. Huh? But how to questions, huh? Come on. Think. Yes. What are you looking here? The first question I haven't finished yet. Yeah? The x, right? So how? What is the continuous method? It's equal to value. First of all, you have your dy dx, right? 3x squared minus 12x plus 9. So what shall I do? Equal, let's go to 0 first. Step by step, don't so big. Hustle, make things easy for you one by one. All these are marked. Alright? I know you need this. Don't show me the way. Big 0. So, this is what kind of form? What equation is this? So, you should get how many x? 2. Look, how to find it? 3 and 1. Alright, so then how to find y? So which equation should I put in? The original equation. Am I right? That's the original here. That's right, am I right? Because the y is here, clearly you can see y is here. So to find the coordinate y, use the original equation. Do not use this. This is dy dx. Okay, how much you get? 0 and 4. Okay. So the first one A is 1, 4. Am I right? The next one is 3, 0. Okay? Finish. Logic, x is 1, 4 is higher up. This one y is 0, at least 9. Eh? Don't put 3, 0 here. That is not logic. You don't even follow the scale. Common sense. Alright, next question. Done. Find equation of the normal to the curve at C. I need you to find this normal. This normal. So in order to find this normal, what I need to find first? Because normal related. Normal does not stand alone. It has to depend on someone. Then only you can get the gradient of the normal. So what should I do first in order to find equation of normal? So before you go, equation of normal. In order to find the equation of a normal line has simple line, straight line. I need to think what is, which is gradient of the normal. Am I right? And gradient point of contact lah. Which point? Ayo. Point of contact. In this case, the point of contact is the C. Am I right? 2, 2. Because your normal is something like that. This is your normal. I need the gradient of the normal. I need the point C. 2, 2. Am I right? But again, I mentioned so many times, this normal line does not stand alone. It has to depend on someone, which is, who is that? Again, who is that? The normal line does not depend on itself. It has to depend on someone else. Then only I can get my gradient. Depends on who? The tangent. Good, well done. The tangent is here. Wow. Understand that? So tell me, how to find this gradient of a tangent at this particular point? Come on. Huh? Sorry? How to find this gradient of the tangent? how to look for this gradient. My question is that. Okay, ready? How to get the equation of gradient? The gradient of the tangent. Normal depends on tangent. Good. At that same point of contact, C. Am I right? But to find gradient of a normal, I need to find the gradient of a tangent first. But how to find the gradient of a tangent? My question is simple. Samir, ready? Samir, ready? Any idea how to find the gradient of a tangent? Come on, guys. I just explained it just now. Huh? Sorry? The dydx lah. Yo, why is it so difficult? Dydx lah. You mentioned so many times. Dydx is the gradient of who? The tangent. Use the dydx. Why is it so difficult? Dydx expression. So what is your dydx expression? 3x squared minus 12x plus 9. This is also known to be the gradient of tangent. Listen. Can. Okay. So you need to know what is the gradient at which point? At C. 2. Am I right? So your x is basically 2. Okay. Put in lah. Your dy dx will be 3. 2 squared minus 12. 2 plus 9. Okay? Is it difficult now? 12 minus 24 plus 9. How much? How much? Thank you. 1. 3. Alright. You had the gradient of a tangent minus 3. So how to look for a gradient of normal? Yes. Gradient of normal, gradient of tangent is always equals to minus 1. This is the relation. Interrelated based on negative 1. So what is the gradient of normal is what we want to find. So negative 1 divided by gradient of a tangent. So negative 1 divided by negative 3. So gradient of normal is basically 1 over 3. Am I right? Okay, simple. 1 over 3. Done. Check. Next, point of contact dot. So how to find equation of the normal? What formula should I use? What formula? How to find equation of normal line? Straight line. Formula? Huh? Yeah, y mx plus c. Simple line. Normal line is a straight line. 9. Or y minus 1 m x minus x. Remember the formulas. Easy for your life. Understand? Okay? Yes.
Why is it negative 3?
So it's not negative 2. That's right. It's true. Negative 3. How do you get negative 2? This is 24. This is 3 times 4. 12 minus 24 plus 9. It's not negative 3. I'm the one doing wrongly. You all got the same answer, right? Our range can learn. Alright. Done. So what is the equation? Yeah, what is the equation? Put in y minus 2, 1 over 3x minus 2. Settle down. 1 over 3x minus 2 over 3 plus 2. So y is 1 over 3x minus 6 plus minus 2, 4 over 3, right? last mark, another 4 marks. Do not waste the mark. Just for a simple question like this, and this is considered simple. Straightforward question, nothing is complicated. No one, nothing is hidden. Understand the graph, understand the word, know what the formulas we use. Yes? Sorry? Yeah, must be one of the things. Okay. Sorry. Alright, next. The last part, find the area of a shaded region. Can I erase this? Because you cannot see. Erase all this, huh? Are you guys ready? Alright, and last question, find the area of a shaded region. So where is the area of shaded region? Use your line, make sure it's clear. This one. And this one, can you see that? This is x equals to 2. This one x equals to 3. Am I right? You're interested is this one. And this is the shaded region. Am I right? But how to find this shaded region? Sami, how to find the shaded region? Come on, Sami. LFB. How to find these? This is what we call compound areas. Am I right? To find a compound area means combination of 2 areas at once. You only need to find the shaded region, and that region is very hanging up. It's very weird because it's hanging upward. It's not even related to any axis. So this is what we call compound. So to find compound, you need to find. Now you need to integrate, yes, good. But before you integrate who first? To find the area, because I'm asking area, not volume, huh? Area. Area, formula, integrate, limit. Respect to dx, make sure y equation, okay? Understand, huh? Compound angle, to find compound angle, you need to integrate who first? Huh? What pi? Pi is volume. This is area. Integrate who? Equation of who? Okay, of the curve, but is the curve. Where is, if you integrate the curve, where is the curve? Where is the curve? This one, right? So if you integrate the curve from 2 to 3, where is the area that you are finding? No? Below, it's always below. Where is the shaded region? This curve, am I right? You are finding this area, right? But that is not what we want. We want on top of it, the blue color. So, integrate this, you got a below one. So how to get this on top? Guys, if you had a compound areas, always look for the area which is in the bigger polygon. Understand? The biggest areas is from both trapezium band. So that trapezium you can integrate under who? Integrate under the equation of the normal line. You can integrate the equation of normal line. Understand? Integrate under who? Under this normal that you find just now. So when you integrate under this normal line from 2 to 3, you will find the whole area. Am I right? The whole area. Find the biggest one, the area under the normal line first. Integrate from 2 to 3. 2 to 3 under normal line. So what is your equation normal line? 1 over 3x plus 4 over 3. Am I right? D I should minus the lowest. Who is the smallest one? What's the smallest one? Huh? I should minus who? I need to find the bigger one. Bigger one. I should minus who in order for me to find the shaded region? Minus area? Under who? Under the line that you find just now, this one. Minus this, minus this. This one, you are finding this area now. Under this curve. Understand? Then only you get the shaded region, okay? So integrate 2 to 3. Same limit 2 to 3. 2 to 3 under curve now. So what is your curve equation? X cubed minus 6x squared minus 9x respect to here. Can you do that? Simple. Integrate. Nothing hidden. Just that how you understand the question. Okay. You get ideas? So I should end my class at what? 11:45, right? So 11:30 remind me, because I had time to start just for you to try. Good. Now please. 11:30. Yes. When you integrate under the curve, when I say integrate under the curve, the y, not the dy dx. Dy dx is the gradient or tangent, different. Two different stories. Alright, to find area and volume, integrate under the function. Okay. Done. So how much you get, guys? What is the answer? Area under the shaded region. Remember, area under the line. This is the line. The normal line minus with area under the curve. Right? Y curve. Put it that way. So, those that is finished can be moved to the most complicated question. Volume. Are you guys ready for volume? Try volume, This one. This is easy. Easy. Number 8. Come. For those that is finished. Volume. 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 before we play with bubbles. Volume. You guys can discuss take 5 minutes to discuss one. Yes. How to integrate? This one. Alright, whoever wants to answer. Anyone yes? Huh? 6. What's 6? Answer. We need the answers. That is the answer. A is basically 6, yes. A is 6. You'll be able to find it. Which one? Which one? Diagram show part of the. So what kind of curve is this? Y equals to A over X. What kind of curve is this? Reciprocal linear. Am I right? Reciprocal linear. Like exponential down. A is a positive constant. Right. A is just a constant, a number, which you need to find later. Given that the volume obtained when the shaded region is rotated, see the word, volume obtained, to find this volume, rotated through 360 about the x-axis. So we are choosing dx as a subject. Am I right? Dx as the interest point, dx. Okay? So when you integrate later, remember, to find volume of this under the curve, I did limit pi respect to dx. So when I respect to dx, this one must be 1 square. Okay? Remember, teacher, where did you get this? Remember, I have to remember this. It does not come to you from the sky. You have to remember. Alright? Even in the data booklet also not given. You have to remember how to find volume. Simple, that is the formula. But the volume is given. Woo! You know the volume. Volume is given. Volume is given. 24 pi. The volume is given. I define for you. Your job now is to find the values of the A. How to look for the values of the A. Your job is this. Your curve is this. A over X. So how to find the volume? Limit from which 1, 3. Am I right, sir? 1 to 3 pi. Your y equation will be A over X squared. Squared, remember, because it's not squared, this is squared. Alright, dx. That's that. Put it all the constant. This is also number. This is 3.142. Hi. Put it outside. So you only integrate 1 to 3 a squared divided by x squared dx. Open the bracket. A squared x squared. Then a squared x squared. Fluid, eh? Alright now. Ian, what shall I do with this? You'll be so tired. Yeah. So what shall I do with this? How to integrate? Bring up. Good. Whenever you see reciprocal, you bring it up. High. 1, 3. A squared x negative 2. When you bring it up, it becomes minus. Am I right? Therefore, dx. Then only you start to integrate. A squared, can I take it out? A squared? Can I take out the A squared? Can I take this out? I don't have to integrate. Can I? Why? Huh? Because it's a number. It's a constant. Like, why? Take it out. You're not interested because you are respecting the x, not a. No. Respecting this letter, not this letter. I'm not interested in you. Get out from my room. So 1/3. X -2. The x. Continue your journey. 24 pi. Pi a squared. Now you start to integrate. Power. Negative. Integrate him. You look so happy there. Integrate x -2. How much you get? Are you negative? Relax. Okay, come. Now, how to integrate this? How to integrate this? How to integrate this? Huh? Integrate. Okay. You help me. How to integrate? -2 plus 1. Listen again. -2 plus 1. Power plus 1 divided by -2 plus 1. Simple. Close bracket. The limit, put it here. 3, 1. Okay? Then 24 pi a squared x -1 divided by -1, 3, 1. Put in all the values. But again, I hate it when I say x power -1, so I change it. Can I change? 1 over. Can? You are bring it down back. It became negative. Negative is outside, so x power of 1. This one 1. This one maybe 1 over 3, 1. So 24 pi a squared -1 over 3, 1 minus is a mass 1 over 1. Okay? Put in the value. Say that. Put in all the values. Minus is a mass in between. So settle down with this one. -1 over 3 times 3 times 3 minus 4 over 3. Am I right? Am I right? Yes. Yes. Plus. Minus is plus. So -1 over 3 plus 3 over 3. Okay? So this one pi a squared 2 over 3. Okay? 24 pi. And now to find a. Okay? How to find a? How to find a? To find a. Come on. Cancel by good. So fast, they're good. Cancel by then what else? You cancel. You like to see when we can cancel? A squared, then what should I do with 2 over 3 here? 24, and what should I do? Times 3 over 2, am I right? Equals to a squared. So 2, 1, 12, 36 a squared. So 8 is basically plus minus 6. So which a should I choose? Positive on privilege. Maths are easy. Yesterday I discussed paper mid-June, 2023, paper 1, 2. You better try that paper. Okay? It's a bit challenging. Any paper that's challenging, please do share with us. Paper May-June 2003, paper 1, 2. Very 1, 2, huh? Try that paper. Especially you guys. Okay? Major this paper. Try this. Alright. Okay. Are you guys ready for Kahoot? Yeah, just try the Kahoot. Get ready. It's all about volume, nothing much. Get ready with your pens and paper. Any question you relate to me? Any question you relate to me? Whoever wins this time, I will belanja for iftar. Okay? Special with me. I'm just kidding. With friends, but I will belanja with you. Dia belanja semua cepat. This is not The curve is y equals to 2 sec x. Find the volume, revolve around it. Top. Only 16, still simple. Come on now. You say x. You are integrate pi. The y squared is 4x. Am I right? 4x, right? Oh, you don't even try. Oh my god. Alright, next. Tsunami, remember tsunami? Tak sedap. So guided. I might try. This is the same. Just that I respect people and respect. So when you respect someone, it's not change. Respect. That one is 12.45. For those who cannot see 12.45. 12.45. They are the same values, but they are not. Whoever can capture my feeling. 12.45. 12.45. Hello. See the word find exact volume. Exact means cannot be in decimal. I know these two values are the same. That is how you treat I treat you. Okay? Exact means cannot be in decimal. Exact, even though these two are the same value. Okay? That is how Russian. Next, who's the highest? Oh, still Irish. Oh my God, Irish. So many. Alright, next. Fight for your time. Fight for your soul garden. Two x plus 3x squared minus 2x cubed. The equation 2x plus 3x squared minus 2x cubed. Question is simple. Find the volume. But the 4 is still there. This is simple, easy. Come on. One point 1.65, right? It's 1.65. 0.85, 0.655. Only dry use, see? Manual. These are good. It's green, manual. Come on guys. Oh, time's up already. Come on guys. Simple question, 1.65. Alright, next. Six. Area. Only for this. This region only. 10 seconds. 8, 7, 9, 5, 4. Wow. Still got blue, red, and green. Is that correct. Please get it wrong. Correct. Wow. What you see? You cannot see. What was it? Something? You're the one wrong, right? He's getting it wrongly. You, one, and? Dad! Why? Why? And next. No more, guys. You put a question like that, you got wrong. Boss, Anis are running for so garden. She's all along. 4 minutes. I give you 4 minutes. It's actually simple. Yeah. But you need to find the point first. Cari first point first. Next is ini bawah lain why spread bawah why this is compound area. No matter if you take bigger size minus the smaller size, then you work with the shaded. No, finish. Yeah. Find this first. This point is how much? 0. It's basically half, man. Half. So integrate under this minus integrate under this. Simple. Use your calculator lah. You need the point, right? You're using without the point, yeah? Simple as that. It looks so difficult like butterfly. Like it's easy. Only this one step to come white. 10, 9, 8, 7, 6, 5, 4, 3, 7. So are these many want to go for so garden? Don't fight. What do you want? You're going tomorrow? The rain works. It works. You don't even need to hide. Just do your shopping and find the special things. You know the find it. Find It's a new one. This one here. Ask them now to teach you. You wanted to know how to use the calculator to find the equation. Ask. Don't be shy. Sophia, can you help me? My name's Mike. Tell me when I the voucher only value for Ramadan. Otherwise, no, you don't. Tell me. You want or you don't want? So how much is so garden? 80 something, right? So if you want to bring another friend, then you have to divide by 2. Understand me? So search anything that is below 50 ringgit. Oh, and sky, 51 ringgit. Sky, dapat Sarah, zoom. And sky, dapat Sarah, and sky is a buffet from our It's a restaurant. You can sit on and sky. Huh? Oh, that's like tadi pagi dua.
Betul kan? Dah. Okey. Pesan you.